Okay, let's start the stream. It's a bit early, but I will talk about the evolution. So what we did the last time, this is the third part and probably the final part, and I just wanted to do it on stream because it's probably not that interesting because it's very similar to what we did in the previous stream. So what we did is put this joycon in a nunchuck. This worked. But this is just the right side. Now we have also the left side, which was buggy actually, but I fixed it. I'll come to that later when we disassemble it. So this is what we wanted to do. And because this takes a lot of time, I tried to have a different approach, and I printed hand grips which I got from Thingiverse to find out if that would be a viable solution. So instead of really putting a controller in there, let me just check if the audio is there. Yeah, no, audio is there. I have a feedback. So instead of putting a joycon in a nunchuck, which I have here, this is the second one. So now we can have the two joycons, the split joycons. I printed some holders from Thingiverse to find out if this is a viable, easier solution, because you just have to print, you don't have to do anything and wait. But I didn't find any. So this one, I liked this for the right side because it has a really ergonomic fit, which holds your finger. The problem is if the spacing of the finger is not right, then you are forced into it. That's not that comfortable, but that wasn't the problem. The problem was this side, when you hold it and when you press on the button, you often still press on here. And this side was getting painful after half an hour. That's not the solution. So this one is not the solution. Then I have this one, which is actually like a nunchuck, but it is a bit too small, and there are still the edges on the side, which are quite sharp and not that good. And the solution here is a bit mitigated because it's larger, but this is too small and the sharp sides are there. So this one is also not the right solution. Then we have this one. This one doesn't hold it well, so here it flips out. That's not too much of an issue. I like this one because it has a gigantic handle, and that fits really well in the hand. There's no issue with my pinky because it seems I have gigantic hands. Let me just a bit the feedback. And that fitted well. The problem with this one is not only that it doesn't hold, because this doesn't have a groove inside, it's just a hole. The problem is that the hand is tilted, and with time this didn't feel comfortable. It's too much tilted from the inside, and I had the same problem. So yeah, I don't know, it didn't feel completely comfortable because you still have something right here. It doesn't fit completely in the hand, and when you try to completely fit in the hand, then it flips away. This one solved it. So this is for the left side. I tried left and right. This one solved it. You cannot press inside again. This one has two issues though. First, it's a bit tilted. That's not the issue. Here, he cut that, so probably you can have a stand. I don't know, but he cut the last part, and my pinky doesn't hold that well anymore. And also, this is not too rounded. These are flat surfaces, so the number of faces for the rounding the designer of this part made is not enough. So, also not the right solution. But it is getting there. You could have a combination of this, because this holds super nice inside, with this, because it's... why didn't this one work? It wasn't too comfortable on the edge here, because here it has this, but this is too small. And then with a combination of this or this, which is larger. But I don't know how to design CAD parts. I'm not a designer at all. I'm just a printer. If I do something, I use OpenSCAD, and these are really primitive forms which I stack. Here, this is not meant for primitive forms, and it would require a lot of printing and trying out. So the solution with having finished model from Thingiverse didn't work for me, and I was really happy with it. This fits really well in the hand. You can completely close it. The pinky is there, and there's there's everything. The buttons here are not ideal. They could be a tiny bit better, but they're still completely usable. So A, X, and so on. So what we will do is still continue the project, and like we fitted the right controller in the right joycon, we will fit the left controller. And if you remember, the left controller was bugging because it tried always to sync, never managed to sync, and never shut down. And this was an issue in the box. So let me put this aside. We won't use it. This too, and this we don't need anymore. We will need this. This I also don't need anymore. This is just the case for the old one. There's no electronics inside anymore. All the electronics are in this nunchuck, and we'll do the same for the left one. What was wrong with that? So I can open it and I'll show you what was wrong with this one. Now we can zoom up. Tick, tick, tick. 1, 2. Oh, and also what I managed now is instead of hanging a Stream Deck where I can tap on Windows to change the layouts, I now have a remote where I can change. For example, if I press on this button, you see the side. This button, you see back. So that's nice. And it's just an infrared remote, which is quite comfortable. And there's nothing to be connected. So 1, 2, 3, there should be a 4th one. And 4, and there's plenty of sun outside, but this will disappear in a moment. Up. So let's open it. Do I need, yeah, let's take opening tool. So how did I fix this controller? Because it was broken, it was never syncing over Bluetooth, almost never, and it was never shutting down. This was simply because the hardware wasn't built that well, and what happened is that, so here we have the 2 buttons, the left and Z left, and the Z left was not the rubber, silicone rubber was not meant completely down here. What happened is that it was a bit tilted and this was pressing all the time. And when this is pressing, it's like a button press and it tries to sync. And because it's continuously pressing, it tries to sync all the time. See, I still continue pressing it. It didn't manage to sync, but because I still pressed on it, it will still continuously sync. And yeah, I think this is a, you see? And that was the issue. And yeah, it's, I mean, it's a cheap controller. The hardware isn't coded that when you press always on the button, that it should only start when you press on the button, so when it changes state and not when it's on the low state. So this we remove. The light, we probably won't use it. We will just use it for debugging. This we also don't need. And so one disadvantage of this one, the lights are inside, so I don't see the results, and I cannot sync in again. Even with the USB, we managed to not think. Actually, this one also has USB, and it even says you could connect over USB. So let's try if this one appears over USB. Let me get a USB-C cable. Maybe the left one does. So let's have journal control. So you can see something. This is screen, and now if you plug, this cable is connected to the hub. If you plug, and if you see something appearing over USB, it didn't manage to appear over USB. Is it maybe a button press? Now we can actually try. What if we press on home? Does it actually appear over USB? No, here it tries to sync, and when it syncs, it doesn't do anything over USB, and only afterwards it does. We also had the issue when put on there. So this is not how USB works, but we've seen the traces and there is USB. So yeah, no obvious way for having it appear as USB device. Maybe by holding the reset button, we'll try that. This is the not, yep. Here it didn't appear as USB. And here is the reset button. And let's try with the reset button. Nope. Doesn't appear as USB even with the reset button. No, so I don't know how to make it appear as USB. I don't know if there's another pad somewhere which you have to press and this way it gets flashed. I think this is how it gets flashed, but I don't know how to make it. So now we can take everything apart. What's this? We will never use. Up, we are already paired, and let me just verify that we are paired. I switch on my switch. Let's go to controllers. I need a remote to go to controllers. App 1, 2. Controllers. Here we have the gripped one. I can now use this remote to switch back. Up. So here we have the grip, and now if I press on the button, because it is synced, it should work. So let's press on this button, and it is paired. Here, this one, pink. So this works, so we don't need to think again. We can leave this here. We will use from time to time the debug. So let's get the board out. Do I want to use from time to time? Yeah. Oh, this can actually be removed. Okay. Yeah, let's keep it this way. Yeah, let's keep it this way. Let's just get the whole plastic. It's maybe easier. So instead of putting the screws on a mat, what you can also do is putting the screws back on holes, like this, and the 4 ones we can put it like 1. This way we know exactly which screws go where. I still like the other method, but I'm too lazy to get my my mat. Well, I can put the screws. This is yet a method, and here. Up, so we can screw this back on. Up, 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 up. And maybe this time it will be faster. I don't know, because the circuit looks a bit different. I'm not sure it will be faster or not. This flat flick here also has. This looks awful. All this resin. This flux. So we will reuse this connector, the joystick. Although I really thought, why not use this joystick, because it fits really well. There are other connections, but you don't have the push button on there. Maybe I can add the push button for the remote here. I also never liked actually pushing on. Yeah, this is what we'll try. We'll try to just to change. We will keep this this remote, so we don't have the hassle of always changing everything, and we will just add a button to simulate this button press on the thing. I've never liked rocking this around and pressing on the button. There are few games, not a lot of games use it, and on the games that use it, I never really liked it. And it makes it a bit more exciting to do something different. So the battery, we'll remove it for now. This up. Yeah. Here's the button, and here the connections. This we probably don't need for now. This we don't need forever. There's also, this can stay in here. And the board. We need to remove the board. There are only 2 screws. Let's unscrew it. 1 and whoop. This glue, it doesn't even hold anymore. But we can remove it. Sticky tape. We will need a lot of cutting, so let's get our scalpel. Yeah, this glue still holds. Let's keep it this way. So 1 screw. And the other screw is this one. We already started unscrewing it. The motor, we will keep it. So we have some vibration. Come on, motor. Yeah, I remember last time I used the pliers because I couldn't get it out. Oh, did I break it now? I hope I didn't. No, I don't think I did. Come on. Come out. Okay. Up. And yeah, the motor will probably also unsolder it. So, this board will be a bit harder. We cannot cut in the middle because it has directly everything there. We'll have to fit all this directly inside. Will this be doable? I don't know. Up. So here we have L1, L2 ground. These connections, we need them. These buttons, oh yeah, they are here on the back. We will need to rewire these buttons. We can remove this and this. Let's heat up the desoldering gun. Let's put back these screws. We will never use the screws again. 1 and 2. This we don't need. Let's have a look at that. So yeah, let's remove this. And here we'll probably cut everything. Yeah, here we'll cut this. And here is this minus button. Oh, will we be able to fit? So this is the new nunchuck. You find it for pretty cheap. And I hope this doesn't have a... No, okay. Whew, I'm happy. This doesn't have three Trident screws. It's just Phillips screw. Yep, just Phillips screw. Up. Oh, this will be really hard to fit. We'll see if we can do it. What we could also do is not have it fit inside, but have all the cables go outside and just connect the board. Although no, then we cannot use the gyroscope anymore. Do we have one? This is very probably the gyroscope. Or gyroscope 3 or 6 axis device. This is the main microcontroller, probably voltage regulator. Here is the transistor for the MOSFET. This is maybe the charger. I don't know. KXL, KX. So let's see what's inside here and how much we will have to destroy this device. Oh, okay. So we will try to keep this. And can we fit it somewhere inside on the side? That's a good question. Let's first unsolder this. Okay, something is crackling. Okay, this is 3. We will have to cut the board. We don't need all the traces. We need only the traces. We don't need this microcontroller. Let's still have a look. Yeah, so I'll probably keep it so I don't have to bother with everything. Now the question is, will we be able to put this board inside? Almost no way to do it. We'll have to cut here and here. Let's do it. The advantage of this one is that we don't have a lot of wire to put again. There's only the 2 buttons and the 4 wires from this connector. We can even cut there and just use these cables if we want to save some margin. So let's get this cutter. Let's check when this one is removed. How is this held here? This way. 1, 2. And this comes as a 1. This comes as 1 piece. And then it holds. Okay, so we need still to do some work so it holds, because as you look, it slides in. You think this pillar. Yep, that fits in, and then the board also gets stabilized using these pillars. So we'll probably have to add some glue so this sticks well if we cut everything in here. We can cut the whole board right there. Not an issue. Oh, here it's even written direct VDD, SCL, STA, and is it in? We can use this board just for the accelerometer. We won't have the buttons anymore. We could still use the buttons, wire the buttons and here, but this allows us to have an I2C accelerometer. The joystick for the other one is also good. The problem is, will I be able to fit this? We will have to cut this part so we can put the USB on the bottom. Oh, what I could do. No, it's more than 4 wires. I could do, let's have this out, up. USB needs to go here. We can never put the board completely, so USB needs to be detached. Now, the board can go up to here. It's far too large. This is the antenna. No, this will never work this way. Let's put it this way without USB. This is also this will never fit. Okay, this is another issue. Can we fit it sideways? Let's have a look. This way. Oh, this could work. If we remove a lot of these pillars, could fit it sideways. Like the other, what we can do is just raise the front a tiny bit. So this could go sideways. We can cut all of this part off. This is just not everything. Yeah, there's a voltage regulator here. No, is it? What is it? I don't know. Is this the charger? There are 2 devices. Probably this is not the voltage regulator. This is the voltage regulator. Oh, I don't know. And we can still cut a tiny bit. No, there's not a lot of we can cut. We can cut here. Tiny bit here. Making it fit will be really hard. And these are structural parts, but we have no choice. We'll have to cut the USB. Actually, if we do it correctly, we don't even have to cut the USB. It fits right there. So we will try to fit this whole board sideways. And let's check. No, we will have to cut it. Even if it fits sideways, it will be a tiny bit raised, but that's probably not too much of an issue. Yeah, but we'll probably have to still cut the traces, plus and minus traces, on this USB. They're not interconnected here, they're connected there. Yeah, let's start cutting whatever we don't need. We can cut right there. The buttons will be up. This broke. And we can cut. So there's a trace going to the button here. We will have to save that one. Let's keep the pads. Let's mark this one. This is KLY. Pen. Forget it. Because I'll cut it here. It's KL. Okay, no, we can directly cut KLY. Going right there. Zoom a tiny bit so you can see what I mean. Because I'll cut KLY, I'll cut these connections, and this is already cut. Up. Everything here is ground, right? Yes, it is. Up, okay. I can call. Oh, this shouldn't be cut too much. We'll just leave enough so you can put the traces back. Oh, there is a trace going. How was it? This was this way. This trace is going to L. We can where is, we can follow it and see where's L. KL1, KL2, damn it, they are here. So I will have these two traces, I'll have to find where they're going, and I need to solder wires on them. Let's mark it. The top one is L1. It's this one, this is L1, and this one is L2. L2. Whatever L it is. Now that it is marked, I can cut everything here. Save some space. Up the antenna. It would be nice. No, I can't. I need still the battery connections. It would be nice if I could cut right at the antenna. But we still need these parts. Let's unsolder the motor. Just with, so it's not in the way. Up, that's done. And that's how much. We need to cut this also. This button, we don't need it, so we could cut. What is this? Is this VCC? Here again, the 5.1 kilo ohm resistors for USB. We could reuse this. Yes, that's VCC. This is where we see it. But VCC is probably not the V-bus, is it? Let's try it out. Nope. Is the multimeter working for you also? No, it is not working for you. I know why. I just connected it afterwards. So, multimeter, connect to it. Connecting. And it should work. And the power supply should also work. Let's try. Yeah, 1. Now you can see multimeter. So is VCC the same as this VCC? Is it the 5 volts from USB? No. No, it's not the 5 volts from USB. Here we have an advantage. We can connect the 5 volts directly on C5. So let's also mark it. This is the USB. And we can cut the board, ground. There are plenty of grounds we can connect to. Are there important traces? No, the other ones are USB. We don't use USB. So let's cut this. Okay. We can still keep the board because we have a connector. We have the 25.1 kilo ohms. We can connect here and here the 2 traces. I could just, in theory, you should need both of them, but one would be sufficient. I'll probably use both. So that's for later. Now we have to fit this inside here and only that. And that might be doable. Let's cut everything inside. Not everything, we still need... how much of this do we need? More the better. Nothing actually. We can cut all these pillars. We only need this one. Okay, we don't have this space. So let's cut just one side actually. Yep, let's just cut one side. The other can remain there. Snip, snip. And yeah, ideally you just have, you print your case, or you would, ideally you just, that would be nice to design the board. Yeah, that could be actually quite good because just take these wires, and then design your own board which fits here. That could be a good solution, yeah, which fits right here. And the board with everything should fit right here in there in normal nunchucks or in these nunchucks. That would be a real good solution if I would have to commercialize these split controllers. Yep, I would just take the nunchuck and have a board designed here, have some wires with the buttons where you can connect directly to the board, and actually even a board which is designed to fit on this. That would be nice. Yeah, I probably will try to do it. I have 3 of them. So what I can do is design a board which fits on the side, even with notches, although I could remove the notches. The USB will get directly in here. The board will go on the side, and then you just wire everything to the board or have a connector. Yeah, a connector. Here you would have, on the other side here, you would have the holes that you'd still need to add the buttons yourself, but then you have the connector which fits right there. I still just need to find, to create a board which is able to simulate a joycon. And that would make it a lot easier. Maybe this could be a good project also. And then you either can, depending on how big the board is, you can actually reuse even the accelerometer, the orientation sensor here. You just use everything from the I2C. All these buttons, you just reuse the I2C connections. Yep. That's a good thing. This is probably what I will design. Just for fun. Having a board which fits right there. So I don't have to design the case. The case is done. It is cheap. You have almost everything. You don't have this plus, but you will have it here. I still need to mod the buttons. And what I could add is 3D print thing which clips on. And where all the buttons fit. That's doable. I would have to test if I can find a library simulating Joy-Con. I think I've seen the protocol for Raspberry Pi that it can simulate it, so it's just a question about spending time on figure out what the commands are. But for now, we don't have that. we don't have our own board, we will have the old board. And over USB, you could actually sync to the switch, just using a C2C cable. Come out. Yeah, that could be really great. A great solution. I have to check how hard it is to implement the Joy-Con over an ESP32. It needs to be to 32. This is also what I didn't realize. I can't use a ESP32 S2, S3, and so. No, damn it! I didn't think about it. If I use an ESP32, it doesn't have a USB, so I wouldn't be able to sync over USB. I can only think over a button, because yeah, the problem is some ESP32s have USB, but these are the S2, S3, and C3. And the C3 is only serial actually. It's not a. Is it a true USB port? No, I think it's just serial. You cannot do your own USB stack. And the problem with them is that they have Bluetooth, but only Bluetooth low energy. The Joy-Cons are using Bluetooth classic, so basic rates and enhanced data rates. And yeah, so if you want to simulate it, you need something which can do Bluetooth classic, which the S2 and so on cannot do it. You can only use the old one. Or you don't use an ESP32. I mean, it's just Bluetooth. There are tons of other devices which do Bluetooth. I have some of them even. The CC, I think 2540, something like that, would perfectly fit the need also. It's small. You can find ready available boards. It's just that I never designed a board with them. But yeah, why use always ESP32? Just use an older one. Probably even have USB, I don't know. It just takes time to switch development environments all the time, and setups and so on, new libraries. But having microcontrollers that fit the need is good design choice. So up, up, up. Okay, so one side is almost empty. There are a ton of Bluetooth microcontrollers now, which are no name. Everyone spins their own out. It is incredible. This is, I'm not sure if this is a custom one. We didn't find any matching pinout for this one, but there are really so many in fitness bands. I took about 3 fitness bands. They all have different microcontrollers, which are brands I've never heard about, well, Chinese brands, and yeah, they all have Bluetooth. So there are really a ton of manufacturers of microcontrollers now. So up. Probably with other architectures other than ARM, because with ARM you have to license. Maybe not. I think, did they make that ARM Cortex M0 is free, or they provide design? I don't know. But generally, you just have to pay licenses if you use their core, which you can adapt. But more and more, if you want to avoid paying ARM licenses, I don't know how much it costs. I never designed an ARM microcontroller. You can use RISC-V. So for manufacturers, RISC-V is probably a good thing. If they could reuse just done RISC-V microcontrollers. And for me, I don't really care if my microcontroller uses RISC-V or something like that. I program in C, and the compiler will take care of everything. So For me, it's not important. What is the underlying architecture? I do some assembly, but very, very rarely. I did some assembly on my 8-bit microcontroller where it was important to you have strict timing requirements. When you have only 8 megahertz and you need to spit out some data in a time accurate way, it's sometimes hard to do it in C. So for that I used assembly, but else it's really rare that I use assembly. I think, yeah, on Extensor I've never used assembly. On RISC-V I've just started developing with it. Maybe I will never need to use that. Compilers are really good. Up. Okay, so now we have all the sides almost not completely flush. It's not very clean, but maybe we can fit the controller in there. That doesn't look half as bad. What we can even do is, yeah. So we have to put it this way because here it's smaller. We have to cut this part. What we can do is remove the pillars so we can tilt the microcontroller inside, the board inside, and if we tilt it, it's not as straight up. So we can even could save some space, but I'm not sure if it's worth it. Let's try to cut this. Ah, damn it, I cannot cut a lot. There's a capacitor there. Would love to cut this part. Could rewrite. What is this for? Ah, it's the other part. Yeah, I have no idea what this thing is for. I'm not sure if this is the. No, I don't think it's the LDO because you have only one capacitor, and generally you have one on the inside, one on the outside. Maybe it might just be the charging circuit for the battery. Oh yes, and it makes sense because I see a trace going for the battery right there. So yeah, this is the battery charging IC. And does it do protection? Because there is no protection IC on this board. Is there a charger which shows also protection? What is marked on top of it? Well, I think we already looked at it. Let me get some magnifying glass and some lights. And actually what I can do, yeah, now that I have that, what is the second thing? I think, no, I just have to press. Let's get the camera ready. Let's press here, and in theory you should see, yeah. So this microcontroller right here, this one, can we then zoom this one? And this has a macro lens, but yeah, it's still too far. I would need another macro lens. Let's see how far I can go. You probably can see what's written on it, but I have no display. I'll just watch by eye. So this is a some glass. Up. Sick. Why is someone ringing? Oh. Oh, I'm back, and there was just someone who was picking up stuff he had lying around in my flat. That's it. So we continue. Still wanted to figure out what this is. So the lamp. We can switch back to here. The lamp. So this was 69B104. That seems to be a charger. 69B104. B104. See if we find something. Let me switch to the full screen. SOT 25 minus 5. Lipo charger. Is it really that? I want this writing to be on it. Very probably a LiPo charger, but I don't find any reference. I wanted to figure out if it has actually built-in protection circuit. 65B, not 69. 65. No RAM, classic. Up. No one does. Yeah, it's nothing. No. The results are horrible. I don't want to know what SOT 25 is. I want this marking. Come on. IC, maybe in AliExpress. No, I don't want an IC. I want this marking. And I said I want this marking. This is stupid. No, they also have nothing. English. Yeah, but I'm pretty sure that's a LiPo charger. We can actually figure it out and try to see. So let's switch back here. We can actually be sure that this is a charger if we just probe the parts. So this is definitely ground. This is plus for the battery. This is plus. Does it go to one of the pins? It doesn't. Maybe I connected it wrong. Because this is ground. No, this is ground. Okay. This is this one. This one. Is this one going to one of these pins? No. Here. Here we have battery. We probably here the 5 volts are directly coming to one of these pins. Yeah, this is 5 volts. We also see the trace sneaking around here. Here's the battery. So this is the charging IC. I don't know if it has built-in protection. No, it can't. I mean, now we can see the VCC. Where is VCC? The 3.3 volts. Because if the battery plus, actually, yeah, what is here? Here we have the plus. Now, if the plus would go to the voltage regulator directly, then this wouldn't be a protection circuit and protection circuit, you probably, you wouldn't be able to have a protection circuit with 5 pins because you have ground, VCC, battery, and probably charging status and something else. Charging status and setting how fast you charge the IC. If you would want to have the protection, you would have the battery go through the device. Is this the case? Is the battery, so here the battery is going here, and is this pin going to one of the regulators? This is for the motor. I expect this to be the regulator or the other one. It's not VDD. Is there a VBAT somewhere? No. Yes, so we have sys reset, no. Okay, so let's try to figure out if this battery goes somewhere. No. Here. It goes here. So the battery goes directly on one of the pins and it has a large trace. So maybe this pin, there is no voltage regulator. No, that would be VDD. VDD would be the voltage regulator. Or is VDD the 5 volts? That wouldn't be. Is VDD the 5 volts? That's VDD. No, VDD are not the 5 volts. So there is a regulator somewhere, but it might be in the chip itself. The Bluetooth chip might have a regulator. I would be surprised because we have plenty of other components, but that could be the case. This is not the regulator. This part is not the regulator, and it doesn't look like it looks like transistor. This also looks like a transistor. This looks like an inertial unit, and I don't see any other parts which look like regulators. So maybe the microcontroller does the regulation, so you save some parts. That could be completely the case because this trace is plus, and the other trace, which is large next to it, is, and this is VDD. It seems the microcontroller is its own voltage regulator. So this is also just a transistor. This too, maybe this is to switch off this chip or other chips for sleep current. Could be. And this is the charger. We can't cut it off, but what we can do is cut this part off. And no trace here. No, check. This is gone. And this is gone. Okay. This is the larger part, so we can cut, but it doesn't make a lot of difference. Oh, does it? We could cut this button. We don't need the reset button. And there's nothing that interesting. Let's try to remove. This is the reset button yet. Okay, 8. Yeah. We could also cut it to better fit in here. Oh, this way it's not bad actually. It's still standing quite high right there. And maybe if we move the pillars and tilt it, it might fit. How about this way? No, that's too far, too high. Must be this way. Let's remove at least this pillar. We will glue everything. To see. Whoa, that was dangerous. how did we put it? Put it this way? Yeah. Yeah, so it does make a difference to cut here, so we don't need to cut this button. We need this pillar because no, we can glue everything. Yeah, we don't need a pillar. We can glue this thing on, and we actually will, because here's a pillar going, and we'll cut it here. So let's also remove this pillar and try to see if we can save some space. So let's also cut these things up. That's the first one. Let's still try it. Put it this way. It does make a huge difference. It does make a huge difference. Let's still make it. Yeah, let's still do it. Everything will be glued in the end, and I will never open it again. Never fix it again. Up. But yeah, designing a board fitting in there would be a nice idea. Nice project, yet another one. But I already have 2 boards I need to design. And 2 boards which have been designed, I need firmware. So, could actually fit. I need to clean a bit more. Scalpel, I'm not sure if it's... Okay. This way. It almost fits. We could cut this, well, we could cut a tiny bit, so we could remove this connector for the battery and directly solder the battery on there. This would enable us to save some space, and then we don't even have to. Let's try that out. Let's try to remove this. So up, soldering iron. Yeah, this is fine. Up. It could fit. Could also remove the capacitor and put it somewhere else if we need this tiny bit of space. We'll see. Oh, but it also means I need to remove the things on this side, right? How much do I need to remove? Let's first remove the battery holder. And I see what is plus, what is minus. Damn it, it's a thing which is soldered on the sides also. We need the hot air for that. And if we have hot air, I need something on the bottom, because else it gets too warm. Tweezers up. You'll probably also melt the plastic because we are at 350 degrees. Yeah, and it's already starting to melt the plastic. I don't care. Up. So this is gone. Up. We'll have to solder. Oh, it's warm. We'll have to solder it directly. It could really almost. We not have to cut the capacitor. And there is a tiny bit of space right there. Let's shave off the space. Oh, it's warm. Damn it. Cool off. Okay. Maybe this. The antenna. Damn it. This might still fit. So we need to also cut the things on this side. Oh, since we don't have the screw anymore, we can get rid of this. Up. Up. And this is also probably structure, but it will be in the way. We only cut it on this side because this is where it matters. The middle. Let's clean it up with the scalpel. Okay. Does it fit? Damn it, this part is in the way. Oh, it does. It fits. I don't know. Yeah, it fits also with the joycon. So now we just have to put the USB on there, solder the battery directly. That's completely doable. And then solder all the traces. So this is a really quick mod. This is nice. I'll still put glue because here it doesn't have any support anymore. There are no screws which are holding, so I will put glue all around to hold everything together. But it does fit. That's awesome. That's a super fast mode. It doesn't need a lot of mod wires. It's buttons. And I need plenty of buttons. Also, yeah, I need, yeah, the sync button, we will not have it. Yeah, we won't have the sync button. We don't care. I'll probably not put the lights, but we have now to just wire the buttons. These things. Yeah, the traces, they are going a bit everywhere, but we can figure out where they're going to. So we can first do this. Should we fit the buttons first and then have the wires going everywhere? Or shall we do already with these buttons? Let's do it with these buttons. We have a board. Up, up. And we can see all the traces we need. Ground, the 3-3, which is ground and VCC. So let's cut right there. Is this holding something? This is holding against there, so let's cut it there. Can still trim off afterwards. Up. Woo, this one's super. This was a lot easier than expected. And now we just have this with an IMU. So if we want some IMU board over I2C, there we have it. I think this is an IMU. Yeah, very probably. And this will be clamped there. We just need all the wires. Do we want to make a cable? So here we have all the RX and so on. We can check with this. What is what? No, we can't. It's not written. But we can probe around. What is what? What is ground? What is plus? And so on. So let's get rid of this. We need plus, minus, so VCC, ground. They are here, RX, TX, the button comes afterwards. And then we have also Z, the 2Z, which are here. And here we will have to solder on the wires itself. Let's prepare these. Did they remove the copper? Oh yeah, it was a bit too far. Yeah, the scalpel has a fresh blade, and blade is already cuts a lot. Yeah, because we can't use, we don't have the Z things here because we had it on the other side. I don't know what L1 is. Is L1 the bottom or the top one? Where is this thing? No, it's not this one. It's this one. I don't know what top and bottom are actually. You can still switch it afterwards. Is L1? I don't have those notes from the previous one. Let's check. So this is L1. This was probably this way, and so this was this way. What was on top? What was bottom? Was it this way or this way? Would think. I don't remember. This was this way. Was the connector going here? I think it was this way. No, we have the holders, so it was this way. So the top one, yeah, and here we have the plus button, the minus button. So the top one is left, and then here we have C. And the top one, I don't, let's see which one is the top one. Top one is L1. So L1 should be Z. Let's note it, else I'll forget it. L1 is equal to Z, L2 is equal to C. And then we have this K7. K7 is equal to minus. We also need to arrange a button for that. We had these two buttons. One is screen capture, never use it. And then there's turbo. I don't use these two buttons. Screen capture, yeah, I never use screen capture. So I won't have a button for that. So we'll still have only two buttons. One is minus, which will be here. And the other one is the C button. The click button. This clicky button. It will be right here. So there will only be two buttons. I don't use turbo, I don't use screen capture, and I will not use the sync button. That's good, that's good. Okay, it's advancing quite nicely. Let's clean this. And then let's continue with the button holder. Up. And the other trace is on top. This is the other trace, and we'll have plenty of wires going everywhere. Oh, I again remove the trace instead of the copper. This is far too sharp. Okay, let's solder the wires on this thing. Up. Let's get this. Let's get this up. Plenty of wires. So we'll first start with grounds. Ground. So the thing goes here. So we'll go from the bottom here. Ground is this big one. Do I have a holder for that? Will this be able to hold it? Kind of. Not perfect, might still be good enough. Yep. So heat up. Still have some solder here. Should be fine. 400 is a bit too big for this tip. Let's put 370. Okay. Oh, we even had said, see, we have the thing. Okay. Let's first have it long enough. We don't need it that long, but we'll cut it afterwards once they're long. Then we have plus. Do we have plus? Yeah, we do have plus because we have some potentiometers, and potentiometers are voltage dividers. Who is the plus? Who is the plus? This is probably this pad. Yep, goes here. And here there's even a, and it goes here. This might be plus. Let's check it with multimeter. This is plus, and it's this trace. Now we can connect it to, I'll connect it right to this. Up. Let's keep it as long. Up. So this color is done, and we don't have enough colors for all the buttons. So we will put 2 times white for the analog sticks. Up. Oh, this is far too large. One. I'll have to figure out which is Rx, which is TX, which is X and which is Y. That's for afterwards. And 2, and I will even mark it. No, I don't need to mark it. We'll check afterwards. Once we solder the wires. So, I know what I'll do. I'll mark that. So this goes here. So this is X, and we will mark X. We will color the cable. We know that this is X. White and black. Or black and white. And now we have the 2 other buttons, which are Z and C. Oh, this is a really... this mod is a lot easier than the other one, where it took 2 streams to do it. Long streams. Up. And last color, I could have yellow. Yellow would have been nice, but I don't have yellow. And these cables are probably far too long. But is cable management an issue? Not that. No, this is not on there at all. Okay. And what's useful is that when I open it, I can still remove the board afterwards. Yeah, we have plenty of space for the cables. Let's keep it this way. And now let's solder them on here. Let's have them all the same length in the beginning, although this makes no sense. This doesn't make any sense because we'll have to split them, but still, let's make it. Looks neat. So, ground. We'll have plenty of grounds actually. Which one of these is ground? Because we'll solder all of them here. So, 1 wire, 2 wires. Can I see it? This seems to be ground. This is ground. This is where we all go. All my cables will go to this ground. Actually, they will even go to this one. Yeah, on the other part with the buttons, all the ground buttons were going to one of these grounds, which might be not that bad idea. And we will try the buttons one after the other once they are soldered to see if it works. Okay. SRSL. Oh, SRSL. Why are there SR and SL? Isn't it 1 and 2? Oh no, SRSL and are these buttons. These buttons, SRSL, we don't use them, so we won't wire them. Next one, plus. I know that plus is somewhere on these things. Which one? It's probably VDD. Let's try to find out where VDD is connected. So we had a VDD somewhere, so this is ground, right? Yep. We had a VDD somewhere. Is this VDD? No. VDD here. Is it one of these? 1, 2. Okay, it's not VDD. There's something else. Probably not this one, because there's a trace going. So it's one of these. Let's have a look here. Is it marked? It's the one next to ground. Yep. Let's clean this up so we can see something. Let's remove all this flux residue. So if I am right, oh no, it's maybe not. Oh, this is VDD. This is ground. This is VDD. It's pin 1 because it goes on both sides. It goes here, right? This is VDD and it goes here. Okay, so this is ground, so it must be, this one must be VDD or plus, something like that. But weirdly, it's not one of these plus. That's weird. This is still ground, right? Does it try to save power and then it removes power from there? From the... Maybe to save power it disables the joysticks. That could be, but that... Because it's not VDD. MIMB, I don't know what it is. And it's not one of the plus pins, so this is the oscillator. If I touch a capacitor, it's also not one of the capacitors, so there might be some trickery going around here. That's weird. But we can try to figure out by just looking what the others are. So this would be plus. What would this be? This is X. That's X, and that's the last button, and that's the button, yeah. So this is plus. Let's solder it on there. Solder board. Solder all of these pads. Actually, was it the right X? We'll see again afterwards. For now, we will solder plus. This is plus. Now we have, is this X? Let's try. If we put it here, X is the one on top. No, so this is Y. Yep, this is Y. This one is Y. And Y is, oh, wrong. This is Y. Y is this one. Okay. So this is X. And X is very probably this one. And the other one is the button press, which we don't have a button for yet. Put it at the end. The two other ones. So green one is C. And C, we said that is L2. It should be connected to L2. L2 was on the other side. Up. put some solder on the pad. This is L2. Green is L2. Yep, that's done. And we check it again. Blue is Z. And yeah, I will put some, once we figured out that this is correct, I will put, and that it is not shorted to the next one, I'll put some glue because they won't hold that fine. So up we have is this one. No, it's not shorting. It's not shorting. Okay, so for power we actually need to solder the, I don't like soldering batteries directly, but if we want to try it we need to. So we'll often put and move the solder and solder the battery. I don't like that. Could we put another connector? No. Up battery, but we wanted to save space, so we needed to do it. First connect ground, or first connect plus, then ground. Nah, it doesn't matter. Let's tin the wires. Let's prepare the pads. Let's solder in the pads. Let's start with ground. This is ground. And then we'll try to connect and see if the buttons and XY work. Up. I don't have the right tip for it. Okay, now it's holding. So if I connect the debug strip, which is somewhere here, if I press on the buttons, it should work. That's the debug strip, and the debug strip was going very properly to this one. Yeah, makes sense. Okay, switch on the switch. No, you're not paired. So now if I press on a button, this one, it doesn't try to pair. Is there no power? Maybe these buttons don't pair. Let's try another button. No. Plus, minus, no. Is there a voltage? Followed 1 volts. The battery is there. It is connected. And minus was minus. Why is this microcontroller not starting? I don't think I've tried anything, and there are plenty of ground connections, and there's no short, because if there would be a short there wouldn't be any voltage here, but there are 4.1 volts. The battery is fine. What is VDD? Let's try. VDD, 3 volts. And it's ground. What's this? 2.8? I don't know what 2.8 is. Power enable is also 3 volts. Why aren't you connecting? Because USB is missing? Nah, you wouldn't detect that. Oh, there's a line on the bottom which are connecting two things, which is connecting two things. Was it? So it was this way, and there's a line which was connecting VCC to here. Okay, I cut a line. I know what I'll do. I'll just, let's all unsolder the battery. I have another solution. Get warm. Up, battery gone. Okay, let's move the battery and we will solder it last. But what we will have in between is just some cables which will be connected. That will be our solution. So let's solder black and white. And yeah, so there's a trace. This trace was going to here, and I think it is. This trace was going here to here. This is VCC. This is also probably VCC. Yeah, there's VDD and there's VCC. And the VCC trace, I cut the VCC trace. I need to fix that. Well. Let's first solder the battery. Don't need a too long cable. Up. This will be, so let's put it back here. Yeah, and I should, before I do any cut, I should test if everything's working. Plus, minus, up. Okay, let's get the right size. Up. Strip it so the crocodile clips can hold to it. Up. Let's set it. 4 volts is nice, but 1 ampere is too much. 100 milliamps should be plenty enough. Let's put 200 milliamps, but 100 milliamps for Bluetooth should be plenty enough. Plus, minus is there. Minus is there a short? There's no short. It uses 6 milliamps, and you can actually also see. No, you don't see the 6 milliamps. There are not enough digits on the screen. But okay, we can control the voltages all the time. That's nice. And now we need to fix the VCC. So this trace will go to this point, and we will use a red wire for that, so we know it's VCC. Let's put some solder on the trace. You don't see what I'm doing. Up. Solder here. Okay. Let's put the wire on one side. Sure it's not connected to ground. We'll put it to the other side. Here. First, we'll do it afterwards. I need to strip this. Damn it. Did I pull the trace? I don't think so. Yeah, I'll have just a wire. Going from one side to the other. Up. It's a bare wire without protection. I'll just test afterwards if there's a short. Up. Let's put some solder on the pad. I need to clean this tip. Yeah, it's a cheap tip. Yeah, this tip is gone. I need to add another one. So let's solder. The bottom is still okay, although it's not splendid. Okay, let's find out if there's a short to ground. Up, up. Now we're in continuity mode, and this is not soldered at all. Now it's soldered. Up. Continuity. There's a short to ground. Is it on this side? Oh, damn it. If I remove it. Yeah, it was on this side. Let's try to clean the surface. Zoom a tiny bit so you can better see what I'm doing. So is this still grounded? Damn it. But this is not ground. Where is there contact with ground? Where is this shorted? Don't have any connections to ground anywhere. Is it here? No. It's not shorted here. This is definitely not. It's definitely not supposed to be ground. Or is it? Oh, it is ground. So it's not this trace which I cut, it's something else? Let's check. No, VCC. This is the trace. No, ground is the other. On the other side, there's ground. This fine line, this is ground. This is not ground, this is VCC. Where is ground? Where is VCC shorted? Let's measure just the resistance and let's try to find out. So 0.32. If we go higher the trace, probably, I don't know what, this is probably also a connector for a battery, I don't know. Okay, that's not it. Is it connected to ground? On the side here? Maybe if I... Crap, not the right one. If I clean that, this is not connected to ground, right? No. And this, okay, it was, no, damn it. I need continuity. That's not connected to ground. This is connected to ground. Why would this be connected to ground? Did I make a mistake somewhere? Is this connected to the ground? Ah. Okay, I got something wrong. This is VCC. And this is ground, right? Yeah, this is ground. Here we have VCC. Ah, no. Okay, we have these two grounds connected. So there's a short somewhere. Is the short near here? Damn it. Where did... Let's remove this. And let's see if there's still a short. There's a short. It's beeping too much in my earphone. So, ohms. 0.19. So there's a short nearer here than here. There it is here. Here we have... There's no short anymore here, but there's a short here. There's no short anymore. Is it because it was in the holder? No, there's still a short. 0.18. The short is not here. Oh! I did short it here. Yep, I mixed plus and this is ground. Yeah, I did short it right there. This should be plus. This should be plus. Okay. Wrong connection right there. So I did short something, so I hope nothing broke. Soldering iron, wake up. It's supposed to be here. Okay. Let's try again with the holder this time, because we know it wasn't a holder. Is this holder actually conductive? Not a lot. Oh, it is. So it shouldn't connect to pads, but that's fine right there. Let's try again. 5 kilo ohms, that's fine. And here, 5 kilo ohms. Okay, so let's put it back to continuity. It's continuity, and they are not connected. Okay. So there was really a short. I hope I didn't damage anything. I don't think so, but we'll see once we solder it back on and once we enable it. And I hope that the remote still works. So if that works, I will also put some UV resin. For now, let's try it on. 30 milli. Yeah, it's already better. And now it went to sleep, but it went up to 25 milliamps. If I press a button, this one probably not. Ah, So let's switch on the switch. Let's press one of the buttons on the back. Will it try to connect? Okay, it is connected. I see it on the switch, and now you see it draws actually, why don't you see it? You should see that it draws 12. Ah, now you see it. It's just not enough. Okay, I have to increase the digits, but it's drawing 12 milliamps. Okay. Yeah, I have to increase the number of digits which is displayed. So, oh, no, I wanted to test if the buttons work. Damn it, now it's off. Now it's on. Let's press this button so it connects. And on the switch, let's go to the settings. You don't see it. Controller. Test input device. Touch. The buttons. So if I press this one, it doesn't work. See, yes, it does. ZL, is this the right one? No, they're mixed. This, yeah, both of them are mixed. This should be, the one on top should be left, yes. And this is the one on top. And right now it's saying Z left. Let me show you. So this is the button on top. So the button on top should actually be left and not Z left. And when I press it, it's making Z left. If I press that one on bottom, it says left. So I need to switch both of them. Let's try if the stick works. Down, up, that works. And oh, what is left, what is right? Here. Left doesn't work. Oh, left and right are mixed. Ah, I didn't expect that. Left and right are mixed. Ah. Damn it. I will need to cheat around that. But yeah, left and right are not... so this should be left and it goes right. So it works, but they are mixed. So what I need to do is actually cut the traces and switch the polarity of plus and minus. That's a pain, but is up. If it's this way, this is top. Up works, down works. Up, down. Left and right are mixed. Switched. On the switch. Yeah, there's only... Also, what I could do... No, I can't. Can I? Just remove the cap and rotate. Can I remove the cap? No, I can't. If I would just rotate this, that would work. But no, I'll have to cut the traces and connect the traces the other way around. Not ideal, but needs to be done. So we can switch this off. And yeah, we need to cut the traces. That's a shame. It would be nice. No, it's only stuck on there, so it should be able to... I should be able to remove the... It's glued probably. And yeah, I think this is not meant for being on both sides. So let's do it. Let's just cut all traces here. And rewire it. That's one side. Let's check if they're cut. Multimeter. So this should not go here. Yep, this is cut and it doesn't. And this should not go here. Yep, so actually, why are you... because I cut the traces only on one side. So this was connected there. This is connected here, and it's not anymore. But the wires are cut, the traces are cut. That's already there. And we only have to cut on one side. Now we just have to put this one there and this ground here. We'll do that using wires. Up. Zoom a tiny bit more so you have a picture of what's going on. So the plus, solder it on the other side. Wake up. The plus was going there, and now it's going, must be going here. Let's cut the wire here. That was ground, yeah, so it's correct. That's plus now. Actually, it should be the other way around. Yeah, let's fix it. It looks better. So let's have this cable going. This cable going here, and this cable going on the left side. It looks better. But it doesn't hold. Oh, no, that's not ideal. And now we do the same for ground. And then right and left should be switched back, and we will retest it. What I can, no, I can't. Have another composition where you see the switch. Okay, ground. Now it's going over all the other wires, and then here. Up. Up. Strip the wire. Connect ground. And let's test if there's a short between both of them. No. And let's test if it works. Switch on, up, power on. Does it actually try to connect when the power is on? Controllers. Let's press one of the buttons. The buttons, we wanted to switch them also. Let's press one of the buttons. So it connects, it is connected. Now let's go to controllers. We need to switch the buttons. Controllers. Yeah, left, right. This is what we wanted to test. Left. Oh, damn it. It's going in this way. So why is left, right still mixed? Ah, I changed up top bottom. I didn't change left right. So now, damn it, I'm so stupid. This was for top and bottom. So now both of them are mixed. What a pain. I didn't pay attention to. So now what we need to do is just mix ground, but here there's ground also. Let's mix ground and plus. So these should be switched, but this is solidly connected to ground, so we'll have to cut this wire and plus the other side. Yeah, let's switch off and let's do it again, but we have to switch these wires. So ground, this should be plus, this should be going to plus, the plus should be going there. Yeah. Let's do that. Let's just cut the trace here. So we cut ground. Okay, ground should not be connected anymore. Let's verify. It's still connected. Is it going the other way? No, it's only going here. Okay, now a ground is cut. Now I have to switch. I need some other tweezers up. So heat up. The wire is not long enough. This wire is though. Here there's plus. Ground switched. And this is too short for anything. Ground needs to go there. Oh, it's too fast. Up. And although, does it? Am I making a mistake? Am I making a mistake? Because now we switch this. Both needs to be switched. That there will be switch ones. No, it's actually this should stay here. Up. It's just the plus wire which needs to be longer. plus needs to go here now. And now everything should work. Let's try. Let's use the opportunity to also change the two Z's. Let's connect that here. And once we're sure, then we can definitely glue them, but let's first switch them. That's one. This is far too long. You could zoom a tiny bit more. And the other one on this trace. Okay, that's the other one. The two Z's have been switched. Now we can try again. Connect minus, connect plus, tack, switch on. There's no shorts. Let's verify if it is connected. Not yet, so we need to press on a button. This one, yeah, it wakes up. And it's connected. Let's try. I can't try up down here. Okay, something is not working. Why wouldn't it work? Grounds are not connected. Without grounds, it won't work. Yep. I need to connect this ground to this ground. One ground to this ground. Or to the one on the bottom. Let's put it here. Up. Okay, ground is connected. Oh, you don't see anything. Okay, it's maybe a bit too zoomed. Okay, so let's try again. Controller, power on. Switch, connect to the thing. Okay, connected. Let's go back. This is so. Right works, left works. Why are top and bottoms mixed again? Top is bottom, but okay, so I need really to switch these plus and minus. Yeah. Oh, let's switch off the power before I make any shorts. Is this long enough? I hope so. Yeah, it seems to be long enough. This goes. Yeah. It's not pretty, but it will work. Don't want to solder yet another red wire again. Okay. And this one. Now it should work. Switch on power. Switch. Press the button. But control is connected. So left, right. Okay, this is on the way, but this works. Bottom, top. Okay, that works. Now the two other buttons. System, controllers, test input device, test control. Actually, can I... do I have a view cam? I need to change it. Actually, yeah, we can do that. No, we can't. No, I can't. So left and Z left. Okay, that works. This is first step. That's nice. And we can decrease the power because it's only using 50 milliamps, so we can control it, limit it to 100 milliamps. So C works. This works. This works. Do we want to put some glue at least on the Z and here too? Because we know it works. We don't have any buttons here. Let's put some glue. Oh, not glue, but UV resin. Up, where is the lamp? There's one of them. So it's the... Here, actually, it's not necessary and probably not a good idea because... No, it's hidden. I'll not connect it to these grounds. I'll have another ground. Let's protect it and then it holds the cables. Up. It will do the same on the board. Ah, you don't see what I'm doing. Now I just put some UV resin and now I'm curing it with UV light. This smell. Ooh, I can smell that it cures. It should be okay. Let's poke it with this to verify if it's okay. Yeah, it's cured. And it's still transparent, so you can see the connections. That's nice. Let's do the other way. The other way. The other two pads. Up. These two. Up. Lamp and cure. You can see a shimmering blue, but because there's 365 nanometers, it's normally not in the visible range. There's still some leaking, and there's a filter in this lamp, so you don't see a lot of blue, but there's plenty of UV. Where is my poking stick? Pokey here. And yeah, it is solid. So the resin is solid. Plenty of UV. Okay. Now we want... What do we want? We need actually the buttons or the USB. Oh, let's do USB first. And then the buttons. Where's my USB? This is USB. We can cut it, although we don't have to. Let's heat up the soldering gun, because we will need to put it there. So soldering gun, not soldering gun, hot glue. Hot glue is getting warm. This can stay here. alcohol, we will need it, and we will need the fan for active cooling. And the 12 volts, which are here. Yep. Now we have active cooling on the bench. So this is USB. We can get ground a bit everywhere, but the 5 volts are on this line and this line. And yeah, so we can get the ground from the leads. 5 volts. I don't know if I want. Normally in the cable the two should be connected. So I shouldn't have to connect the 5 volts, but it's the proper way to do it. I don't know if all the cables do it correctly. So I will need to connect the two 5 volt traces. Let's expose. The traces. Yeah, okay, you're not seeing what I'm doing here. Up. And the ground will just get it from the bottom. 30 VG will be plenty enough to charge. Even if there's a voltage drop, I don't care. It's only charging up to for the 2 volts, and I don't think that there will be a voltage drop of 0.8 volts. And it's probably a linear charger. So heat up. Okay, no, damn it. Up. Doesn't have to. I don't remember. Does it have to be long? Let's make it longer so it can go all around the board. Let's make it this long. There'll be even a higher voltage drop, but I don't remember which direction it had to go. Okay, we can solder ground on this ground, and the plus was... Actually, was it on the other side? Yes, it was. Okay. Can actually solder on both wires on this side. Actually, I don't remember how I put the board in, but it did work in. Yep. So, on the capacitor, which they didn't populate, although they did one, but not both of them. The other one was probably too expensive. This is ground. Okay, that's there. Then we have red for 5 volts. And in theory, I should connect both of them, and I will. Yeah, I will. But only with one wire. I need to hold a hole. Up. Oh, I do have another holder actually. Yeah, I do. Yep. Put some solder on the trace. This is the 5 volt trace. Okay, and on the other trays also. Yep. First 5 volts. We need somehow to put the second 5 volts. Can I burn the wire? So I can access the trays. Probably. Yeah. Ghetto style. Okay. The 2 pluses are connected. We'll put same wire length here. Let's get it right there. Damn it. I need to pay more attention to the things which are all around, breaking everything up. And then we will check if there's a short before we do anything. So let's not enough solder. Okay. Let's connect. Yeah, is there a short between the 2 plus 5 volt, the 2 5 volt and ground? Beep beep. No short. And then we will try with USB. So normally if we apply USB, we should see some charging on the battery. Let's try it out. So let's connect the power supply to the port. Let's not enable it and let's try charging. Here we have micro USB. We connect it, yep, and it charges at 4.19 volts. It tries to charge it, but it doesn't work because there's no battery. So now if I switch on the switch and if we go back to controllers and go to controllers, you're not seeing everything, but I don't want to show you the switch all the time. Now I connected it, so but it's not on. Yeah, and it says it tries to charge, but it flickers. If I put some power, it does still try to charge. Oh, that's fine. With the battery, I think it will be fine. So charging works. We can put the glue afterwards. Now we have all the buttons which we need to wire. All the other buttons. Is that all? Yeah, the battery in the end, but we'll put the battery completely in the end. All the buttons will be here. Now what is... Ah, here's 5 volts actually. What are all the buttons? That's a pain to check. Up. Up is probably... Ah, the buttons will be all wrong. We have the minus. The minus is... Actually, where's the minus? Is it Kyle 3? Kyle Y? Kyle? Where's the minus? That's this, so it was here. Oh, it was Kale 3. I think Kale 3 was the minus. I have to connect here. Here we have a ground. This is the clicky button from the left. We have plenty of buttons, so now what we need to do is put the buttons on here. All 6 of them, and then make holes. So let's do that. We'll use the same buttons. let's have the stand to clamp it down while we put the buttons up. And in the end, did we use epoxy? Because, yeah, we used epoxy because the other glue was with acetone and it was eating the plastic. So we'll do it again with epoxy. Yep. We have a tiny bit of paper. We need 6 buttons, so let's zoom a tiny bit more out. It's not that fine work. And here we will have, yeah, this will be up, left, down, right, minus, and left button. Left stick. Buttons, where are my, here, DC buttons. Here's my box with all the buttons. And we need these buttons. And I already forgot, but I can look at the other handle. Yep, we just need side to side. So we need 6 of them. 1, 2. We could also have, no, we don't want sync and I don't want screen capture. I don't care. 3, 4, 5, 6. Could have plenty of other more buttons. It's just more to wire. Up. So we can cut the tabs on the side because these are single pole double throw. And it saves a tiny bit of space. Let's prepare all the 6 buttons. Okay, let's prepare the glue. Where is my pokey stick? Here. That's plenty enough. So this is 2-part epoxy. It gets really strong. And it cures in 10 minutes or so. Okay, how did I arrange the buttons? This way. So button 1, we'll put just glue on the bottom here and we will stick it. How did I do it? On the other controller? On this way. Okay. I should put some gloves on actually. I'm sure we'll have some epoxy on the fingers. One, two. As long as they don't cover the pads, that's fine. Because I'll need to solder the pads. And I like these reverse action pliers. So if you don't hold it, then they put some pressure and you have to press on it if you want to release the pressure. Damn it. And I did release it too soon. So that's right. No, that's left. How do I want to do it? It's undecided yet. This will be bottom, left, right, top. Yeah, probably, but I don't, yeah. Let's clean thing. It's already starting to get hard. It needs more time. While this is going on, what will I want to do? Oh, it's not hard at all yet. Okay, here we have the 4 buttons. This is not getting like I want to. Okay, 2 buttons on the top. Shouldn't be sliding all around. And we'll need to wait. While we wait, no, we cannot do the remaining parts. I don't want to put the USB because then I don't. Let's put it this way. A bit more to the top. Better access to it. One and last one. This one here. Now we have to wait before we can drill. And why are you sliding? Do I have to adjust that so you stop sliding? Okay, we have to wait before we can make the holes and then solder the wires. What can we do meanwhile? Not a lot. We could... I want to glue everything in the end. We can make longer wires for the motor. That we can do. So we don't need this anymore. We don't need this anymore. Oh, no. This was the K7 button. What was K7? This was minus. This is what we need to wire. So we need this to know how it is. This we don't need anymore. This is trash. Where is the motor? I put it somewhere. It would be nice to make the wires longer, but I need to find it. Here's the battery. Let's leave it here because we know. Here's the motor. There's the motor, and we'll just make the wires longer until this dries. And this just needs time. And we will have the witness here. If this is dry, we know that this is dry. Okay, so let's make these wires longer. Let's use the same colors. Yeah, we can. And there's enough space inside the remote for putting wires a bit everywhere. We don't need to have the sleeves now, so let's put it up so you can try, and now we can continue with our work. Wake up, soldering iron. How long should it be? Should be plenty enough. Put it where we want it. We will glue it in place. We will glue everything. And blue. Then we will put some shrink tube. Damn it. I got some glue on my arm. I will have an epoxy arm, epoxy finger. Let's put it somewhere where it's not in the way. Somewhere where I can still witness it. This is not sliding anymore, that's fine. It's trying to get dry. It still needs 5 minutes or so. Okay. Yeah, this should be long enough. And we can even solder it directly on the board. Once we put some shrink tube on this thing, shrink tube, here's shrink tube. There's plenty of colors. Blue and red. And we don't need that long. Can be a lot shorter. Up. Blue, put it back in there. Let's have the hot air station at 200 degrees. It would be nice to have multiple settings. Where you can set different temperatures, because you don't need a lot of different temperatures. Very often I have 350, 400 and 200. So 350 is for general desoldering, 400 if it's a huge plane, and then 200 is for heating shrink tube. And we can zoom a tiny bit more. Okay, that's one. And the other, then we'll solder it on the board. Okay, that's done. The board, here the two motor contacts. Make it a little bit shorter. Which one is plus and minus is not really important. We'll just turn the other way around. Up. So here we have the motor. Next thing, this is, oh, it's getting stuck. That's good. It's not completely dry, but the buttons are drying. And yeah, our witness shows that it is getting sticky and it is getting hard. It's not complete yet. What else do we want to do? We don't need the buttons. All the 6 buttons are here, so we need to wait for the 6 buttons. Let's prepare the drill. Now it's again the machine which makes a lot of noise. This and the tiny drills up. And I'll cut the audio while I do that because it's too noisy. This is thick enough. Yeah, I could even use a smaller drill. This is... That's perfect. So let's use the small drill. Let's put this one back. I think I even lost the drill. Yeah. Do I see it on the ground somewhere? No. Too small. Okay, we're in drill setting. The next question will be, where do I put all the grounds? Do I connect all the grounds here? No, I can't anymore. They are all covered. So I will connect all the grounds here, but that's plenty of wires. Or I connect all the grounds together. That will also be a good idea. Then I have only one ground. That's a good idea. I'll do it this way. I will have only one ground, and this saves a bit of space, and I'll connect all the grounds together in there. And the same trick we used actually for V-Bus, where I heated up the wire enough. Yeah, I'll do it this way. We'll see if it... maybe it won't work this way. But I'll connect it. I'll connect all the grounds together on this pin. I need to figure out which is... let's see here. We don't have up, down. We have A, X. So these are here. A, Y, X, B. And I think KL3 was KL3 the buttons? I don't remember. I didn't mark minus. So let's try to find out where minus was. This wasn't this way. It was this way. So it was going here. Where was it going? SR? No, this can't be SR. Where was this button going? I can still... it was this trace. So I can just connect it to this trace. Yeah. Let's connect it to the trace instead of the pads. Oh, let's script the pad. Let's figure out where it goes. No. It goes here, 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 here. This point. Which point is this? Up. This. There must be a pad for you. There is no pad for you? Maybe the pad was on the... No, it wasn't here. Was the pad here? Yeah, it was here. So there is no pad for it. So we need to put it on the trace. Let's grip the trace. Okay, trace is prepared. Let's put some glue on there. While this is drying. This is almost solid. Let's wait a tiny bit more because we will put some stress. And meanwhile, let's glue the motor, the USB, and the motor. Where is my UV lamp? UV lamp, harden the resin. Oh, the buttons are shiny on the UV. Let's zoom a tiny bit more. So you can see what I'm doing. My pokey stick says, yeah, the glue is cured. Yeah, this resin is also cured. Let's do the same for the motor. But I should clean it a tiny bit. It looks really ugly. Alcohol. Alcohol. And also, it's not just it looks ugly. The resin wouldn't hold that well. So, motor. Blob of resin. Up. Let's cure it. Oh, something will not work actually. Yeah, the motion control with the accelerometer could detect it correctly because it won't be flat anymore. Maybe the calibration is able to do it. I don't know. But there are not a lot of games with motion control. Not a lot of which I play actually. Might be more. Okay, that's cured. So let's make holes for the buttons. And for that, I will shut off the audio because else it's too noisy and it will explode your ears. But you'll see everything. Okay, we are back. All the holes are done. Let's put this away. And now we have to wire everything. And this can go. Oh, it doesn't hold that well actually, but maybe when it hardens a bit more, it will hold better. Do we want to wire? Oh, there are plenty of weird things. Do we want to wire first the grounds? That's probably a good idea. So let's have one ground and let's connect all of them to ground. Up. Where do we want to start? We will start with the top and we'll go clockwise. And always the right one, the left one, this. So I need to prepare the pads, soldering iron, solder. Okay. Okay. I did burn the plastic a tiny bit. I have to be more careful. And we'll keep it short because we will connect all the grounds together. And it only needs to get to the... Actually, how do I want to do it? Yeah, it needs to go up to here. Next one. Oh. I will change the tip. The tip is too large and I make too many mistakes. Up. So switch off the soldering iron. Oh, he is my thing. Get the plastic. This is not the tip I wanted. I wanted this tip. Move the warm tip and let's put it somewhere where it can cool. Let's put the other tip in, and for this tip I need to go 400 degrees and up because this is a fine tip. Okay. So how do we want to do it? To put it in here. Strip it. I hope this project will be done today. This is too long. I'm confident. I think it could be done in 1 hour. I just need to solder all the buttons. The main worries are taken care of. It's not the right strategy which I'm using to solder the buttons. Oh. This is not completely dry. I was able to move the button. It probably will need 24 hours to completely cure. But this works. So this only needs to go here. We will do it with a soldering iron. Then we need to put the button somewhere here. Up. Which one? So this hole, right? Yeah, it's the right hole. Yeah, this tips allows me to be a lot more precise. Does mean that I won't do any mistakes, but at least I'll do precise mistakes. Then get the wire in. This goes to the next button, so it's not a lot. Let's keep it still a bit. It goes only here. I need to pay attention. Don't want it to be too far away. Here the joystick will, I hope it doesn't scrape on the sides. We will see. Okay. Actually, I should do it the other way around. Oh, this is also, yeah, it needs to cure a bit more. It's not completely hardened yet. I'll probably also put some resin afterwards so it covers this thing, makes it a bit smoother, and it makes it so where are the other buttons? On the outside. Oh, damn it. We'll do this and then the other one. And this goes on the back. And the other one will become the long one, the last one. If I manage to get it in. Oh, because it's the long one, I can do it from this side and then I can cut it. Okay, it was a bit too early. The plastic cuttings from the drill are sticking to the epoxy. Yep. Now let's do it the other way around. Up. This long should be plenty sufficient. It's holding in, and now we need to connect all the grounds. We'll do it by melting plastic. The insulation. Yep, that works. But I need tweezers, the bit finer one. Let's put some solder on there, and this works. It's not super beautiful, but it works. Actually, if I make a board, I need to find a design where this is done easier, because this takes a lot of time. Yep. Those work better than I expected. Up. And this goes on the back right there. I'm sure audiophiles are crying because I'm not doing a star ground, but daisy chain ground. Daisy chain ground. Luckily, you probably don't press the buttons more than 20 times a second. So you don't reach the 20 Hertz hearing threshold. Okay. Everything is holding. We'll see in the end which button don't work. Now we can wire the buttons. And we have colors for that. We have only, let's use 3 colors. And let's repeat the 3 colors. Actually, why don't I have a green? Ah, here, no, we have 4 colors. Let's use the 3 colors. Let's not use red. And let's do the 3 other colors. And repeat them. And I have no idea which button should be what. Let's put solder on all the other pads. Okay. Let's clean this tiny bit up. Okay. This should be minus. Let's have the cables long enough. This will be left joystick. Let's use the next color, white. Why not? White not. And the last color, well, the last for the first group. There will be plenty of wires inside. That's okay. Ah, damn it. It wasn't soldered properly. Okay. Continue with whites. Yeah, white is done. We can still make them shorter if we need to, so they will have the same length, but for now, keep them long. This doesn't look like it's soldered. Go around here. So blue. This doesn't look beautiful. Okay, better. And the last one was green. And then we need to figure out which are which. We know two of them, that's for sure. We don't know the other was. So, plenty of wires. Which we will now solder to the board. Let's get the board, get the wires out. Yep. And there's one which we need to put on the back, but first, let's do one after the other. Let's start with ground. Ground, we can put it to the other ground. Okay. It's not a beautiful solder connection. I'll try to improve it a tiny bit. Okay, this holds better. And the cables are not that long. I hope this was not getting on the bottom, because that would be short. Now, this one was the minus, and the minus was on the back. Where's this thing here? Here, this trace. That's minus. This one was the clicky, so we don't need anything from this side. We will put some resin afterwards. This one is the clicky button for the right. And this is right. This is right here. Next, the green one. The green one is left. Left is equal Y. Left is equal Y. That's right here. Then we have this one is equal to bottom. This is P. No, down. Down will be B. Let's see if it works correctly. Let's switch afterwards. Then the blue one is right. Right must be A. And the right one will be top. And top is X. X is right here. We don't have buttons for the other ones. So now we will try to connect power and verify if the buttons are correct. So let's switch on the switch. Switch on the glue gun. Close. Let's go to set system settings. Controllers and sensors. Test input device, test controller buttons. And for now, we also need to connect the clips for the power supply. 1, 2. Switch power on. Switch. We know that these buttons work, so let's switch on using this button. Oh yeah, it's already connected. So this is left, that's correct. That's Z left, that's correct. Then this should be left joystick, that works. This should be minus, that works. That should be bottom. Oh, that's left, damn it. This should be left, that's top. Okay. This should be right and this should be up. Okay, they're not at all how they are. How do I need to mix them? So this one, which is top, should be left. So it should be with, where's left? Oh, it's because I'm pressing the button. This is left. So green, it should be go to this. And this should be top. So I need to switch the 2 greens. And this means that I need to switch also the 2 other ones. So the 2 greens and the 2 other ones, because the ones are not correct. 1 green, 2 green, 1, and the other ones are the remaining ones. There's not a lot of choice with verifying with, it should be fine. Okay, so let's switch on power. Let's see if the controller directly connects. Why didn't the motor turn? Normally when it connects, the motor turns. Is the motor dead? Oh no, I switched off vibration. That's why. So let's try the buttons again. Left button, right button, that works. That's top, that's okay. That's right, that's bottom, and that's left. That works. So they all work. I'm not sure if this configuration is makes the most sense. Going to the left is going to the left here. Going to the right is this is going to the right. Maybe this should be top and this should be bottom. I don't know. I can still do the remapping on the device. And here just maybe it makes better sense that this is right, this is left, this is bottom, this is up. Now it makes more sense. This is down, then you go here on the right. And then if you go on the up. But most of the time you don't use this pad. This pad is just for options, so you probably get used to it. Okay, so let's put some UV on there. Some resin, so it holds. We have all the we need to put it also here. And one on the back. And then we can switch off this. Then we can put the battery. Should I have a longer battery? Yeah, I'll probably connect the batteries to these leads actually. So we have longer wires, so we can also put some glue on, some resin on here. This allows me to move the battery. So let's cure everything. Let's have some battery connections. Let's be sure everything is cured. Okay, the glue gun is warm. Let's solder the battery and then let's put everything back. No, test. Last time test everything and then put glue, hot glue everywhere. The battery, I think I've put it here. Yep. Shrink tube, black and red. We had a tiny red and black. We have plenty of them. Up. We need to shorten this. 1, 2. 1, 2. This should be long. Yeah, this should be long enough. So minus. Then we can really test. Yeah, we'll test. Put the shrink tube first. Ground plus hot air gun. Oh, there's a detector. Actually detects if it's not on the holding. That's weird. How does it detect it? Is there a motion controller? Or there's a maybe there's a reed switch in here, and there's a magnet on the holder. So let's heat up the battery also with the hot air. Lithium loves to be heated up to extreme temperatures. Okay, so now we connect. So we can connect by pressing the button. Okay, it's already connected. Said left, that's right. That works. The motor we don't care. Charging. To see the charging. Left, right, but we need to go back and down, up, left, back, left, right, and charging. It doesn't say that it's charging. Controllers. Okay, it is. It says it is charging. That everything works. I cannot switch it off though. I have to put everything now in the case somehow. So let's start with this thing. Let's glue this in place. The joystick. The two buttons, they've been lost, but I'm sure I can find them. Here's one of them, and the other one shouldn't be too far away. This I can put it away. Where is the C button? Here's the C button. So, Z button. C button. Here's the holder. And now I need somehow to put glue. Where do I need to put glue? And the corners? I can put it on the side. So normally it should hold like this. Okay, let's put glue. So let's glue. Oh. Why aren't you gripping the glue? Okay, now you are. 1, 2, 3, and this should probably be enough. And this way around. Then we will try to semi-close it and see if the stick is okay. The stick is okay. Should probably also put some glue on the back. Although I don't press on the buttons, but a tiny bit on the back. Up. Let's cool it with my fancy fan. My fancy. Oh, almost 4 hours. I hope we're done in 20 minutes because I know that the microphone doesn't hold much longer. And probably the audience also doesn't hold much longer. But this stream is meant to be in the background for relaxing for whoever likes my voice and see a project. Oh. Okay, I need to put some more glue here because this feels mushy. Maybe it's held by that, I don't know, but maybe it is, but it feels really mushy. Up. So let's try to close it and see if the joystick works. You go maybe I should put also some glue around the wires everywhere to hold them in. No, I won't. I'll just press fit everything. No, I'll put some glue because I'm sure that they won't stick where I want them to stick. So let's put a tiny bit of glue here. And on the other side too. Oh, I didn't put it correctly. Now it's correctly. The fan really helps a lot, not having to wait so long. For so long. Yep. Let's put this side. Okay. Doing. Let's try to close. It was really holding everything together. I can't close it. The glue is. So this is not meant for glue. Yeah, I have to remove this glue. Okay. I don't know if I have to remove the other glue too. Let's see. Okay. Two. Okay. Now the other thing is that's fine. Although that's not completely fine. I should put glue down under it and not on the side. Let's put it this way. And I need to remove the glue on the side. I can probably put the glue on this side and the other side. Let's first remove the old glue. Let's remove this glue. I need to put more glue on the bottom. I can also put some on the sides. One side, the other side. Yeah, the sides are fine. Yeah, and the bottom I need to put a lot more glue. This way it should be fine. Let's remove the soldering iron for now, so I can place the glue gun here, because I need it more often. Yeah, okay, that works fine. It doesn't, well, here on this side, but I think the stick will cope with it. And yeah, now this closes correctly. And now let's glue this. Let's have a USB cable to hold it in place. I glue it in. I should put, yeah, let's try it this way. Let's put some glue and then let's slide the connector inside. Up. Damn it. Up. I'll still clean it up with the scalpel afterwards. I think we also need to cut a tiny bit the case because the USB-C is bigger than the... Yeah, I think we need to. It's not holding super well. Okay, that was a fail. Let's continue with the glue. And we'll just cut everything as we need it. No, it's not cold. Yeah, I have to hold it until it's cold enough. Almost. You see it's getting blurry. Yeah, we need to cut also here. Yeah, we need to cut a lot. But let's wait until it's close. I should put it. Oh, it's not holding on the side. Oh, okay, it's not holding at all. Let's remove everything and let's do it again. Tuk, tuk, tuk. Could you cut it maybe deep? No. Let's cut these sides so the cable fits better in. The grounds. Yeah, should be connected. That's fine. And we tried it. It is charging. Let's put the cable back in. Yeah, that fits a lot better. Fits a lot better. Can even put, although it doesn't make much difference, but we can put it a tiny bit on the side. So it uses less space and doesn't look that horrible. I'll heat it up afterwards. Let's first have it glue a tiny bit. I think for the glue too dry. Oh, the red one, the red wire didn't hell. Ah, damn it, let's fix that. Damn it. This red wire didn't hell in place, hold in place. Sorry, Aaron, wake up. I need to put more solder. Let's put the switch to sleep. So it tells the controller go to sleep. Okay, hope it's not connected to ground. We'll test it. One lead, the other lead makes beep. No, it's not connected to ground. That's fine. So let's glue it once for all inside. That's at least one side. We'll do the other side afterwards, and now we'll just wait till it dries. Okay, kind of holds, but not a lot. Let's wait a tiny bit more before we add glue. Let's not be too. Yeah, I want to be finished in 15 minutes. Is the audio still working? Yeah. Okay. We'll cut everything afterwards. Cool down, glue, cool down. It's not cold, else it will be foggy, and it is still translucent. Up. I then need to decide where to put the motor and the battery. Now it is getting starts to get not yet. Cool down, glue, cool down. Ist the audio working? I'm not hearing myself. Did it switch off the audio? The audio should be working. Why can't I hear myself in the headset? Audio, output device, HDMI, Raven HDMI. No, it's working. Okay, this it's not holding that well. Let's put some glue also on front. Okay, this should work. Yeah, we need to clean a lot of it. Okay, then we have, let's try to climb a tiny bit. Okay. No, it's not cold enough. Probably need the battery here, and if I have a space, the motor here, but we'll see right away. Yep. I have plenty of space. Well, plenty of space. That I'm not sure, but okay. Can I put USB in and out? Yep, that has holes. So let's try to fit this in. How should it fit? This way or the other way around? Maybe it's not that important. Oh, all the cables have to go here. I hope they're long enough. I really hope, because this definitely fits this way. Oh, has to fit. Okay, it has to fit this way down with the buttons up. Battery. It fits. I hope the cables are long enough. Oh, they seem to be long enough, but it's tight. These cables should go around in the back, so they're not in the way. If I can. So the motor. Let's glue. Let's remove a tiny bit of glue here on the back. This way we have a bit of space. This one. Let's remove this glue. I hope this way it fits better. It's not cut correctly. Okay. So we will put the motor on this side with some glue. And the battery will be flapping in the breeze. No, it has a tiny bit of stickiness. But I need to remove this plastic so I can actually fit the battery properly in. Up. Okay, we said that the cables need to go around here. This way. Oh, maybe the battery needs to go the other way. Yeah, the battery needs to go here. Let's put some glue also for the battery. Up. I don't think the board needs any glue. It will be stuck into it. Yeah, damn it. Now we just need to fit all the wires. They do fit. You should, yeah, go this way. Don't pull on the thing. Okay, now try to close the device. Okay, it holds, closes here. It doesn't close on the bottom, but that's not too much of an issue because we will put glue here. Before I close it, let's switch it on and it needs to close. Let's switch it on and try if it works, if everything works. Oh, okay. It says so. Up, down, left, right, don't. That's okay. Oh, this is a bit too high. Ah, that's doable still. Let's test all the buttons. System settings, controllers. Now I can show you. I can show you so it doesn't reflect. Okay, now I can see. Up, test input device, test controller buttons. This is, damn it. Okay. That shouldn't be left. This, so these two work. Damn it, this doesn't work. This doesn't work. And all these buttons. Ah, this works, this works. Why? Okay, something broke off. These three don't work. These three work. Damn it. No, they're still connected. Ah, the ground has broke off here. Ah, okay. Now this is where the plus the stick. Okay, so the grounds need to go on the side, and this is why they don't work. It broke off. That's fine. I need to fix this ground issue. So how do I want to fix it? This. Up, and I already covered the grounds. So we will do it a better way. Soldering iron. Glue gun, you go out of the way for now. I'll need you a couple of minutes, but for now I need to fix grounding issues. So I would need, let's also move this ground is connected. Let's put all the grounds on here, and let's have one ground cable. Maybe it's long enough, so we can connect it here. Could be, I can connect it here. Okay, let's remove this. Let's add plenty of solder here, and let's try to connect to this ground. Okay, it heated. Okay, this ground light also to be connected on this wire. And I'm smelling a bit of plastic. Yeah, I've burned the plastic right there. Okay. The grounds should be connected. Now if I press on the button, no, still not all three of them, so this ground doesn't seem to be connected correctly. The other ones look fine, and it's the three buttons, so I'm pretty sure it has to do with this connection. Let's try if it works. That works. That works. That works. Why? Did I break off the plus? Now I see. I see why one button's not working. I didn't cover it with resin to secure it in place. The red wire, which was going here, has been ripped. And where is it? Yeah, the one which was going here. No, it's not. It's still here. So, controller. You not working. You not working. You okay. 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 And you're not working. These three are not working. So means that this ground connection is not correct. Put some more solder. We are almost done. Okay, this ground connection should be fine. Now, test control pads. Yeah, minus, left, works. Let's put back everything together. Yeah, on the bottom it won't be perfect, but this we will fix with hot glue. Okay, top works. Cable go in. And the bottom is almost closed. It's not perfect tight, but it's almost there. This cable go there. We will just put glue and then that's it. So glue gun. Then we also need to, because we don't have any screws anymore. This doesn't look smooth. Okay. And now we will heat it up and then make it flat. Okay, let's try. Damn it. Oh, we can do it this way. You're not seeing what I'm doing, but I'm doing it on the edge of the table. Okay, that's glued. Let's wait a tiny bit until it's hard. We need to make also the other side better. And it feels pretty smooth. Get the glue out on the sides. Okay, now let's heat up the other side and let's flatten it also. Maybe this way you can see what I'm doing. Up. Just heating up the glue, and then once it's heated up enough, I go with the finger. That wasn't a good idea. I did remove the glue. I want to add some glue, just not a lot. Okay, now I can, yeah, that's better. Go with the finger. Move all the glue which sticks over, and that's it. It's not perfect. I feel I need to that's not ideal. This doesn't feel nice on this side. Yeah, this doesn't feel nice. I need to make it a smoother degradé. Sweat and Kill cools down. Okay. Okay, now it feels nice. Now I don't feel anything. Oh, surprisingly, I feel the bottom right here. No, I do feel something here. This should be a tiny bit flatter. Oh, we didn't try if the sticks are working. I think so. Won't see why. Let's test the buttons. So that's top, right, left, click, right, and the joystick. Oh, button said. Oh. This button doesn't work. It does. But it does something else than left. It does something, but it's not left. It's like home or back or... No, it's up. I don't want to open it again. Why is the left button? Damn it. Yeah. If I press here, it's like I would go up. Damn it. I need to open it again. But I want to do it now. I think the battery is dead. We are over 4 hours of streaming. I'm hungry. And it kind of works. I mean, it's now I have my other remote. Just need to fix this button. I'm not sure where it got wrong, if it's here or if it's right here. Here it should be fine. Put a lot of glue and protection, so it should be somewhere in here. But I'll open it and fix it another time. But for now, this project is completely finished. We have a left remote, a right remote as joycons, so joycons in nunchucks. Pretty happy about it. And yep, that's the end of the stream. So if you want to build it, you know how it is, and still think that it could be worth it to build custom PCBs to do that and fit it inside here. Now you still have to manage the buttons, but still think it's possible. Okay, that's it for the stream, and enjoy the rest of the weekend. Bye bye.